Addition and subtraction with fractions. So the rule says this: if you have a over c plus b over c, then you can add those numerators if the denominators are the same, and you get a plus b over c. And we have a similar one for subtraction. It says if you have a over c minus b over c, if those denominators are the same, then you can subtract the numerators, a minus b over c. So that's the rule. But sometimes the denominators aren't the same, and so when they're not the same, we have to get them to be the same. And we have to find what's called the least common denominator. Now, the least common denominator is the same thing, well, it's the LCM of the denominators. So sometimes you'll hear it referred to as LCD for least common denominator, and sometimes they'll just say LCM, meaning we're finding the least common multiple of the denominators. Okay, so here's an example. We have 7 over 12, example 5, 7 over 12 plus 11 over 15. So the first thing we have to do is figure out what the LCM is going to be, or the LCD. So we want to know the LCM of 12 and 15. Now you could do a listing, you could do that method, but I'm going to do prime factorizations. So 12 is, I'll do a little box here, 2 times 2 times 3. Now I happen to just know that, but you could do a factor tree if you wanted to, and that's how 12 breaks down. And 15 is 3 times, oops, I didn't leave quite enough room, 5. Okay, so now I think about, well, what do I need to get the least common multiple? I'll need 2 2s. I'll need a 3. I don't need 2 3s. One's good enough. There's no more than 1 3 in any line. So 1 3 is enough. And I'm going to need a 5. And if I multiply that all together, I'm going to get 60. So that's the LCM. Now, kind of a cool thing about doing that way, you'll save your work over there to the right with the box and everything. So I have 7 over 12, back to my problem, plus, I'll leave a little space, 11 over 15. Now I need that 12 to become a 60, but, let me do something real quick. Okay. But that 2 times 2 times 3 is just, very similar to what I had right here. It's just missing the 5, right? So I need to multiply by 5. And if you don't like doing it that way, you could just say, well, how many times is 12 going to 60? But it's kind of cool that it's already broken down for you so you can see what factors are missing. So then for the other one, the 15, what am I missing? I'm missing the 2 2s. So I need to multiply by 4. Or you can divide 15 into 60 and you'll get 4. Okay, so we multiply by the missing factors so that we can get denominators of 60. We call this building fractions. So for the first one, I'm going to get 35 over 60. Now don't reduce that. So we want it to be 35 over 60. I know 5 will go into both of them, but I want it to be 35 over 60 because I'm trying to get a common denominator. Plus, and the other one's going to be 44 over 60. And again, we're building these fractions. So yeah, they reduce, but don't reduce them. Not now. Okay, later in the end, if they reduce, we'll do that. Okay, now we can add the numerators. So, yay. So what's 35 plus 44? That's what we're going to do over 60. And notice that you just keep that 60 the same. That's your denominator now. So 35 and 44 is what, 79 over 60. And I think 79 is prime. I don't think anything will go in there, so I'm going to leave it that way. Now that brings up a question about mixed fractions. Do I want to make it 1 and 19 over 60? I don't. So you can make it a mixed number. If you were going to the hardware store and you needed 79 over 60 inches of lumber or something, you wouldn't say 79 over 60. You'd say 1 and 19/60ths. But in math, we usually like to keep it what's called an improper fraction because it's more user-friendly. We could go and multiply or divide with it and do other things. It doesn't simplify, so that's why I'm leaving it 79/60. Now you might say, well, how do you know it doesn't simplify? One way you could do it is, where did that 60 come from? That 60 came from 2 times 2 times 3 times 5. Does 2 go into 79? No. Does 3 go into 79? Well, add 7 and 9, that's 16. 3 doesn't go into 16. And does 5 go into 79? No, it doesn't end in 0 or 5. So you could use your divisibility rules and you could see. All right, that was kind of a long conversation on that, but good stuff. All right, example 6 then. We have 3a over 4 minus 8 over 9. So what I need is I need to know the LCM of 4 and 9. Well, 4 is 2 times 2, if I do my little box, and 9 is 3 times 3. So I'm going to need everything. I'm going to need the 2 2's and the 2 3's, and if I multiply that together, I'm going to get 36 as the LCM. All right, so I'm going to have to take the 3a over 4, multiply it by something, and the 8 over 9, I'll have to multiply that by something. Okay. So for the 4, I'm going to have to multiply by the 2 3's. Right? So I'm going to multiply by 9. I'm just going to put dot 9, but you know, you can put that in parentheses too. And for the other one, I'm going to have to multiply by 4. Okay, so what do we get for the first one? We get 27a over 36 minus 32 over 36. So we got the denominators the same, that was the goal. And now how are we going to subtract those? Well, all we can do is write, oh dear, I don't know where that came from. Where that? I've lost my screen. Okay, we're back. Sorry about that. Okay, all I can do is write 27a minus 32 over 36. Now, let me talk about that answer. That answer, in the numerator, they're not like terms. 27a and 32, they can't be subtracted. So I just have to leave it that way. However, I want to leave it as one numerator and one denominator. I can't do any simplifying here, but I can write it so that I just have one numerator and one denominator. And that's what I want to do. So that problem is done. That's the way you write the answer. So there you go. All right. B, part B. This is not adding or subtracting. This is multiplication. Now, multiplication is a different set of rules. You don't need common denominators for multiplication. All I want to do is simplify this. So I can write my 3 times a. I can break it down into primes. 4 is 2 times 2. My 8, if you remember, is 2 times 2 times 2. And my 9 is 3 times 3. And then I can cancel factors that are the same. So if I have 1 in the numerator that's the same as 1 in the denominator, I can cancel it. So the 3 is out with one of those 3's, and one of the 2's and another 2. Okay, that's what can cancel. So what do I have left in the numerator? 2a. Remember, you're going to put the number, the coefficient, in front of the variable. So it's going to be 2a over 3. And we're done.